Okay, hello everyone, and thank you for joining our session on integrating BIDS datasets into LinkAhead. We are IndyScale, a small company focused on research data management from Göttingen, Germany. We're very focused on open source and recently built an integration for the BIDS standard. And my colleague Henrik will give us a talk today about such standard. Welcome, and Henrik, please take it away.
Thank you, Thomas. Okay, yeah, integrating BIDS datasets into LinkAhead will be the topic. And to start, what does this integration mean? So BIDS is a standard for how you store brain imaging data, basically in folders, how you name files, how the folders are structured. So it is a good standard which allows interoperability, which allows sharing data, because more scientists know what files are, how they can be used, and they are easily, or they are more familiar with the structure that they see if BIDS is used. LinkAhead, on the other hand, is a research data management software, and because you might not be familiar with LinkAhead, I will first of all give you a short introduction of what LinkAhead's main concerns are, how data management with LinkAhead works, and then we will have a look on how the integration of these two will look like. Okay, so first of all, for the introduction of LinkAhead, I want to point out three challenges that typically occur when you do research data management. The first is the data linkage, meaning that there are connections among data. For example, the connection between an analysis and the corresponding raw data, and these connections are often very valuable. So they must not get lost. They must not get lost, and we need to make sure that they are preserved. And LinkAhead does this by storing, for example, metadata directly with the raw data, and by having really a native representation of those links, so the data is embedded in its original context, and the system makes sure that these connections are not broken or do not get lost. The second aspect that I want to touch on is the dynamic environment we face in research. Research questions change frequently. The kind of data that is being processed might change, or the way the data is being processed might change. So you need to have a setup that is capable of changing or corresponding to those changes. And in LinkAhead, we model this by allowing the user to change the data model, so the kind of data that is stored, what attributes you are recording him or herself, instead of, like with traditional systems, having a fixed schema that you cannot adjust and where you have to define it once and then stick for it basically for eternity, or pay huge costs to change it. So the third thing that I want to mention is findability and usability. It's nice to have a lot of data, but it's basically useless if you cannot search it properly or cannot access it properly. So the access is really at the core of this. So for example, if you have metadata stored in text files, this might be easy to store, but it can be difficult to search those metadata then. Or relational databases are, of course, very powerful with regard to searching the data that is in there, but they are, on the other hand, very hard to use for end users and basically backends, and basically no one is using them directly. So in LinkAhead, we try to combine the best of both worlds. We have a search capability that allows users with an easy language to search the data, and yet have very powerful semantics, which means you can be also very specific on what you retrieve, so that you really can ask a specific question to the system and, for example, base further analysis on the data that you receive there. So one example of what you could ask would be, giving all the types of analysis that were performed on a certain campaign data before a certain date. All right, so where does LinkAhead locate itself in the research data lifecycle? When you start with data acquisition in the bottom right here, you maybe do experimental work or numerical simulations or both, or even other sources of research data. You process them and in the end probably publish it. And this again poses new research questions and the whole process starts anew. So LinkAhead is supposed to be a tool for the researcher after the data acquisition. So once data is acquired in a digital form, it can be integrated into LinkAhead, and from then on you can work with LinkAhead to access it more easily, search it more easily, and monitor the whole research life cycle until the publication. So this enhances reproducibility, for example, because if you have a publication, this publication may reference the analysis that went into the publication, and those in turn may reference the raw data that was used. So you can really have a full picture of what was going on. So to summarize, with LinkAhead, you can easily search your data, precisely access the data that you need for a certain question. You can easily create overviews of what data is already there. Yeah, I already mentioned that metadata and data is directly linked, so important information doesn't get lost. And you can build upon existing practices for fair data management instead of thinking about all the different ways that are possible on your own again and again. And the last point here is that you can change the way the data that you use is described yourself without the need of IT personnel or large costs to change the system. All right, so the workflow would look like this, and this is already important with regard to BIDS, because we already mentioned that BIDS is basically a way how you store files and name files. So in general, with LinkAhead, you start typically with files. You can also use other sources like databases, but this is a typical way that you have some kind of files on a file system, typically a file server, and the files may stay there. Often they are huge, so you don't want to copy them somewhere else, but they are integrated in LinkAhead, which means the location is monitored, and you enhance the files with metadata or extract metadata from those files for better searchability and easy access. And of course you can do this manually, but the typical way and the recommended way would be the automation. For example, with the LinkAhead-Crawler, which can monitor a file system like a BIDS folder, and then integrate the data automatically. So once the data is integrated in LinkAhead, you have multiple ways to access the data, for example, via a web interface, which gives you a nice way to look at it, especially for exploring the data. Or you have programming clients in Python, C++, C, and so on, to allow for automated data analysis. All right, so I mentioned that you can use different data sources to integrate them into LinkAhead and basically break up different silos of data that might exist. And one very meaningful data source is electronic lab notebooks. And therefore I want to mention our prototype for the eLab FTP integration that we have, so that if you do an experiment in the lab, you might have recordings from some machine, you have the notes that you did in your electronic lab notebook, and you might have numerical simulations that don't occur in the lab but still need to be integrated with this. And yeah, then this integration helps to combine all those different sources and work with them together. And how this looks like, I will show you in a moment. And yeah, so we have this prototype, and there's another YouTube video where we show this, and we're currently working on enhancing this prototype to make it a real productive use or productively used integration. All right, with this, I want to just jump into the live demo of showing how you do the integration with BIDS. And just one further note, there's a public available demo instance which we host. It's on demo.indyscale.com, and there you can also find more details on what features LinkAhead does have and how it is used. And while I kept the introduction into LinkAhead quite short here, the concepts of the kind of data management that we do with LinkAhead is also explained in more depth on the demo site. So with this, I want to jump into the integration itself. So I wanted to show this here. So there's a Git repository on GitHub, BIDS standard / BIDS examples, which I checked out here, which contains lots of folders with, basically BIDS compatible data sets, which are not real data sets. They only have the file structure, and then the files are basically empty. But for illustrating how you work with this is a great tool. So let's just jump into the first one. If you are in this session, you probably know BIDS, but just to give a quick introduction, there is a dataset description JSON, which is the most important metadata file, which stores information about what this data is, which BIDS version was used, who are the authors, and so on. And then there are subject folders, which correspond to the subjects. So the subjects that were measured with, for example, MRI devices. In these subject folders, there's one or more sessions. So, for example, a session where a subject went to the hospital and had the measurements done. And in these sessions, there are folders for various modalities. It's called in BIDS slang, so to say. So different kinds of measurements, basically, that were done. And then within those folders, there are the files, for example, raw data files like here. And they follow a special naming pattern. For example, you see here that the subject is encoded in the file name, the session is encoded, and then there's a suffix which tells us what kind of image data is contained in this file. And these are, for example, pieces of information that are used for the integration. So this tells us what the file is, and that's what our automatic integration will be using. Okay, let's jump back here. So now that we had a look at the structure of a typical BIDS data folder, this is the web front end of LinkAhead. Here's a demo instance, so it looks exactly the same. However, I will use a version that is running on my computer for this presentation, so I can really change whatever I like. Okay, so let's get started. If we want to look at the data sets, the BIDS data sets that I already integrated here, and I will show you how you integrate even further data sets, I could start with a simple query like find dataset. All right. So you see that I integrated already 2 of those exemplary or example data sets from this example collection. This is the one that we just looked at. And each data set has here such a record. So this R in the upper left stands for record. And this is the kind of atomic data entry that we have in LinkAhead. So everything is represented in these kind of records that have certain attributes. For example, this data set has as an attribute or a property, as we call it, the BIDS version and the name of this data set. And then there is a list of the subjects that are associated with it. And as you see here, there's a type of data set. We call it the record type. And this, of course, is the data set. The information in those data set records are basically from those data set description JSONs. And we can also open it here. So you see in this data set description JSON, there's really the basic minimum only. And that's why this record also has very little information, while this one has a little bit more. So apart from the dataset description JSON, we have the subjects. So let's have a look at one of them. So the subjects are also represented by such a record, and they have quite little information, namely they only have the label that is associated with them, and they reference the 2 sessions or how many sessions there are, that would be in the BIDS standard located within the session folder. The session in turn has also a label. However, now it's getting more interesting because the session also references the kind of data acquisitions that are located in the session or that were done in the session. So for example, here we have anatomy imaging, there's 1 reference, and then MRI field map data, there are 2, and functional imaging, there are even 3 of them. So we can in LinkAhead use this small eye icon to have a quick look at what is behind such a reference. So we kind of see the record here within the other record. And we see that the anatomy imaging record might have an acquisition label which is not set. It could have a run label, but the only thing that really is existing here is the actual file. So it's a TI-weighted image to give you a better idea what we just did. So I think I used the subject number 1, then session number 1, anatomy imaging. And this is basically the file that we are looking at here. So this is so far basically only another representation of what you also see in files. And you might even argue, well, it is faster for me to just click on the folder than follow these references here. So why do we even bother doing this other representation? So the reason is that LinkAhead comes with quite a few features that help researchers with their research. For example, searching the data. So that's why I want to show you a few examples of how you can search this BIDS data now that we integrated it into LinkAhead. So let's start with another simple example. By the way, so I cannot introduce you fully into LinkAhead. For example, the kind of queries that we send here to the system, like explaining it in detail would be a full training. So I can only briefly touch on that. Yeah, more to that regard later. So if you want to search for basically anything, you would typically write find and then the kind of data that you're looking for. So another or another record type that is coming with the BIDS integration is functional imaging, which is another kind of data acquisition. So if we send this query, you see there are 129 results of different functional imaging records. So this could be already useful to directly see how many of certain data acquisitions exist in your whole data set. Or so in BIDS, one data set is basically one of those BIDS folders that we saw. And if you have a project or in your lab multiple of those BIDS folder BIDS data sets, you can get an overview over all of them already using such a simple query. But it is getting more interesting if you pose conditions on what you are looking for. So for example, you might write that you are interested in those functional imaging data acquisitions that were done on the second run. So this, as you see here, there's typically this run label. So you might say, okay, for whatever reason, I'm only interested in those that have run label equals 2. So we see the run label property here, and I can add this condition like this. So this restricts our result set to only 42 of the 127 or what it was functional imaging data sets. And this is kind of the first aspect where I think you see that it's easier to simply create this result set with such a query than running through all those folders, going into all the functional imaging folders and then picking the one. So here it is not even shown. Here, so run label is this in the end, and then selecting the ones that are the correct file or the correct run. So this, I think, is the first example, and if you want to be even more specific, you can also use the fact that these functional imaging data acquisitions are referenced by the sessions in which they were recorded. So we saw the sessions before, they also have this label, and we could therefore make the query even more specific and say that this functional imaging shall be referenced, so, and which is referenced by a session, for example, with label 1. I don't know if there are any, let's see, yeah, so this is probably kind of half of those. So what I want to illustrate here is that with the query language, you can be very specific on what data you want to use, and you can use basically all the attributes that were inserted here. So if you, let me get back to the find data set. If you look through the data, you can use all of those attributes. You can use the labels and everything that you see here. So you can use all the attributes to restrict the data that you are searching, and you can use the references between them. So you could also search for all the data of a certain project or of several projects. I think you get the point. All right, so this is already a nice way to have a look on what is there. You could also create tables. For example, there's something like select run label. What else was there? Okay, let's just use the run label only for the moment. Select run label from functional imaging. Oops, select run label from form. Oh, typing is hard. All right, so with this slight change in the query, instead of find, I used the select, and with this you can create tables. So for every property that I have here, I create a column. Now I only used one, so there's only one column, which is a little bit boring. And behind each row, there is this record from before. So this is easy to kind of combine the data that you want to have, and then you can directly export it as a file. Let me quickly log in. So you can also export Excel file, or you can copy and paste a Python code snippet to create this table within Python. So it shows you how you can quickly access the data and then continue working with it, whatever tool you prefer to use. And this is kind of a good transition to what I want to show you next, namely how you use this. For example, in Python, I have this Jupyter notebook here, and I want to quickly show you how you can access the BIDS data that you integrated into LinkAhead using Python this way. All right. Okay, so if you want to access any data stored in LinkAhead, and this reminds me of that I wanted to mention something in the beginning, which I didn't. So if I type now the command here, you might ask, wait, what is he doing? So import KSDB as DB. KSDB is basically another name for the same software. It's the name with which the project started. And we try to consolidate this now. So in future, we will only have the name LinkAhead for the whole project, because this caused lots of confusion in the past, because we had the two names for the project, and from now on we will stick to LinkAhead. However, this process of consolidating the name is not yet done, so this is why the Python library is still called KSDB. But this will change in the near future. So import KSDB as DB imports the Python client for LinkAhead, which allows us to access the data here within Python. And then I will also add matplotlib pyplot as PLT for plotting. And okay, I already executed this. So let's see if we have access to the LinkAhead instance, and you see this, we have a connection. My example instance only has 404 records. All right, so now we have a connection. We can access the data that is stored in there. And first I want to find out what kind of data acquisitions do we have. So executing a query looks like this: execute query. And you type exactly the same query here as you would in the web interface. So there's really no difference. And in order to find the kind of data acquisitions that we have in our BIDS datasets, we would type find record type data acquisition. So there's hopefully no typo. All right, and we are only interested in the names of those record types. So the name, so we will get back a bunch of objects, and the name of those record types is then stored in the object attribute name. So we simply do l.name for l in our query result. So what we do here is we get all the record types, data acquisition. Maybe I should do the same once here. So find record type data acquisition. Okay, so these are the record types. Functional imaging is one that we saw before, and I do the same here now. And I'm not interested in data acquisition. I'm not interested in the data acquisition itself, which is also, oh, where was it here? Which is also one of those record types. So I'm only interested in the other ones. And now let's have a look. So those are the data acquisitions that exist: functional imaging, MRI feed map data, and so on and so forth. All right, so now that we know what kind of data acquisitions we have in our data, we might ask ourselves, okay, how many data acquisitions of each of those types? And for this, we could create a new array where we execute query where we send some other queries. Okay, typing and thinking is also hard. So what am I doing here? So I want to send count queries. They are just like the find queries. However, they only return the number of results, so not the objects themselves, but only the number. And so I want to count each of the types that we just had and put them into a list again for name in DAX. So I hope I did this correctly. And DAX. Yeah, so we have some numbers here, and now I simply copy the code for, no, it doesn't work. Because a plot, of course, is nicer to look at than just those numbers. So we can create a plot from the statistics. So we see that the functional imaging data is the one that is most often in this data, in the two data sets we just that we already have, and then some of those are not in there yet. Okay, so getting these kind of statistics is again quite nice, but not what you really would do if you do actual work. So if you do actual work, you would probably be interested in doing some computation with the files themselves that are in this BIDS dataset. So if you want to do computations on some of those files, well, first of all, you need to find the files that you want to process, and second of all, you need to download them. So to find them, we would send another query, db.execute query, find file physiological recording. So this is another. So this is actually the type of some data files. Let's get back here. So we had this functional imaging data acquisitions, and you see here that the physiological recording is a type of some of those files that are attached to this functional imaging. And if we now would send this query, or let's do the same again once in the web interface. So you see now that we actually get files which also have a file path, and I could click here to download the file. So I can also directly search the files, and if I do this in Python, I get kind of file objects from this query for physrec in. So with this, I iterate over the file records that I get back from my my query, and then to download this file, I would simply do file name equals physrec .download. Okay, so this .download returns the file name, which is a temporary file name, where the file object is stored, and then I can do whatever whatever I want to do with this. Yeah. After this, I have a file object that I can work with. So I could, for example, do with open file name. I probably only need to read as file, and then work with the file as I would normally do. So from here on, basically working with the files is the same as if I would use the file objects directly from the file folder. However, I can combine the data from different BIDS folders or in a way that I find suitable for my analysis. All right, this should be the end of the Jupyter demonstration, so which is just an example of how you can use programming clients to access the data that is stored in LinkAhead. Now let us focus on one further aspect, which I think is really one of the major strengths of integrating something like BIDS into LinkAhead, which is that if you have one dataset, like one BIDS dataset, it might already be quite convenient to work with it, and you might also already have tools that can filter the data and give you what you need. However, what do you do if you have other datasets that are not stored in the BIDS format? What do you do if you, for example, have an electronic lab notebook where you would like to access the BIDS data and the data from the electronic lab notebook kind of at the same time? Yeah, you want to do this kind of analysis, but make it dependent on some other data that stems from some other source. And the point here is that you can integrate those different data sources into LinkAhead and thereby combining them into something larger. So to illustrate this with a very simple example, I used here basically the data that we also have for our public demo instance, and this has the data record musical analysis. So basically it doesn't even matter what this is. What I only want to illustrate is you might have some other data in the same LinkAhead instance with some other properties and so on and so forth. However, it might reference part of the other data set. So for example, here I reference the subject, which in turn has those sessions. So if we look at it, the same subject is referenced by a musical analysis and a BIDS dataset. And simply due to this aspect, simply because we have two different objects referencing the same subject, so two different datasets which are interlinked, we can use this to refine the data that we're looking for. So the simplest way to do this would be, so let's show you the first thing. First, find subject. So find subject gives you all the subjects. And in these two BIDS datasets that we integrated, those are in total 24 subjects. But you might ask yourself, okay, I'm now interested in those subjects for which I also have this other kind of data set, in our case, the musical analysis. So posing this question would look like find subject, which is referenced by musical analysis. And you see, with this, I reduce this result set that I had before to only those where the musical analysis references the subject. And to illustrate you that, this could be something different. So I actually did a mistake here earlier. So I added a subject here as well, but didn't give it any property. So I hope I don't by chance now select the same one. Okay, let's do it again. Find subject which is referenced by musical analysis. Okay, now we have those two. So I think this illustrates that those references can be used to restrict the data. And the important point is here that it can be references from whatever projects, whatever data you integrated, you really can make use of all the data that is in the system. And while this is a quite simple example of this, let me show you one further aspect. So now we only had a look at the subjects, but of course you can extend this to the sessions, to the data acquisitions, as you like. So for example, extending it to the sessions would be find session which is referenced by the subject, which in turn is referenced by the musical analysis, and then we get those. So these are twice as many because each subject had 2 sessions. Okay, I hope I made the point clear that if you integrate multiple different data sets or data from different sources within LinkAhead, you can connect those and you can really work on all of it at the same time. You can use properties of all of it to restrict your queries to really find the data that you are interested in at a certain moment. All right, so if you want to get in the weeds of how you do this BIDS integration, let me first show you gitlab.com/ksdb. So here we currently have, and this is the same naming issue, so in future it will probably be gitlab.com/linkahead. But for now, all the code related to the LinkAhead project is located here. And the KSDB crawler, which is the main tool to do the integration, would be this. And crawler seafoods is where we started to collect our kind of more specific versions or modules for this crawler, and then we have the BIDS seafood here. So this basically contains the specification for how to integrate BIDS datasets. And I don't want to show you now how you set it up completely, because this would then be a little bit longer video. But in turn, I want simply to show you what you would now do if you already have it set it up and you have a new BIDS dataset and you want to integrate that as well. Okay. All right. So the command is this here. Can I like this? Okay. So we call the KSDB crawler. Debug flag doesn't really matter. Then we can tell it whether it is allowed to update existing entities or only to insert new entities. We can change the path where the file is located within LinkAhead. So there's this file system here where we see, for example, this example dataset that we saw earlier, and you see that it's directly named like this example without this BIDS examples folder, which is why we remove this BIDS examples folder from the path. Then the BIDS seafood is the repository that we just saw. It has the definition of how the integration should look like, and I can quickly show you, for example, well, I do this later. So the specification and then simply the path to what I want to integrate now. And if I run this, I realize that I don't have my environment enabled. Activate. So let's do it again. Okay, so there's some not that easy to read output, but it doesn't really matter. We can, for example, simply copy one of those IDs. So this is one of the IDs that were just inserted, and let's go up the reference tree until this new data set that we just integrated. And also if we do the query that we did just in the beginning, data set, you see that these are the two that we had in the beginning, and now there's one more which I just integrated. So this shall simply tell you this KSDB-Crawler is the module that I showed you in GitLab. If we add --help, this was to like this. Okay, so it also has a help that tells you how you call this tool. Yeah, so you would need to set up a LinkAhead with a file server that it can access the files, and then you can use this tool to integrate BIDS datasets into LinkAhead. Right, so I wanted to show you a small introduction on how the crawler works in turn. And for that, I need to go back to the slides. Okay, so I now talked a little bit about this KSDB-Crawler or LinkAhead-Crawler. So let's have a look at what this does. So on the one side, you have files like the BIDS files or databases. So data that you want to integrate into LinkAhead. And the crawler is a tool to run over this data. Also, it can also be done iteratively, for example, monitor a file server continuously. And you can have certain so-called seafood plugins, like a seafood for BIDS, and then a seafood for your electronic lab notebook and other kind of integrations. And it kind of creates a fingerprint for data. For example, it uses some identifying properties of an experiment. So this could be, for example, the date and the location where an experiment would be done. So if you know at a certain date, at a certain location, there can be only one, I don't know, MRI imaging experiment, then you can use those properties to check whether the experiment was already integrated into LinkAhead. Well, the crawler does this check, and therefore it can identify whether data is already existing or whether data should be added to the existing data. And yeah, to give you an example of how this definition might look like. So for example, here we have the data set. The data set is solely identified via the name. The functional imaging data acquisitions that we saw earlier, on the other hand, are identified by the acquisition label that they have, the task label, the run label. So not all of them need to be set, but kind of the combination of those makes them a unique functional imaging data set, functional imaging record, and then a session that references those is also important. So because you might have different BIDS data sets with the same labels, however, then you would have different sessions. So if two functional imaging objects are not referenced by the same sessions, they are not in fact the same object. All right, this also should be only just a brief introduction of how the crawler basically works. So it tries to identify data objects in LinkAhead to realize whether those need to be updated or whether something needs to be inserted as new data. With this, I'm coming to the end. So the current limitations are basically that we so far do not use all the data that is stored in such a BIDS structure, but we use the dataset description JSON and those key value pairs in the file names. And of course, there might be other interesting information, for example, in metadata files. So there are these sidecar JSON files. So this kind of data will be added later to this integration. And also the types of records that we use could be in future more specific. So currently we use the same record type for also slightly different kinds of objects. I don't know whether I have a good example at hand. I'm afraid I don't, but imagine that you could have one type here and then two files here, which are not exactly the same kind, but are roughly the same. So then this is kind of a coarse class of objects, and we could be more precise in future. And there are still some special BIDS modalities that were not yet integrated because this was done for specific projects, and this covers quite a bit of the BIDS standard, but is not yet fully compliant. And yeah, these limitations also kind of imply the outlook. We want to integrate more of the parameters in future and also be more specific with the record types. And in I could also add the third point here. Of course, we would like to be fully compliant with what this standard says. Okay, the last slide is kind of a collection of the different resources that are available online. You are invited to join the community channel where users of LinkAhead can exchange about their projects that they do or what problems do they have with integration, for example. Then there's a newsletter which you can sign up to get news about new LinkAhead releases or new integrations that are being added. So as I mentioned, this BIDS integration is only one of many. You might also use some electronic lab notebooks, so you might be interested in this kind of integration as well. And yeah, the online demo instance that I mentioned, the source code, documentation, and a reference to a scientific article where the concept that is behind this is explained in detail. All right, with this, I would like to thank you for your attention, and yeah, I'm glad to hear back from you.